Hello, my name is Tavis Flanagan and welcome to the base number formula. This video covers how the number system is constructed and how the base number formula works and some background on the subject. So, if you take a random number, say 183,745, what do you do with these digits to make that amount? If you were to sum up those digits, it would only make 48, and multiplying them makes 3,360. It actually requires a whole formula, where the digits indicate how many ones, tens, hundreds, thousands, 10,000s, 100,000s, and so on, depending on how big your number is. Then you sum it all together, and you get your number. You may have noticed that all the ones, tens, and hundreds and such are all powers of 10. That is because in our culture, and most modern cultures, use 10 as their base number with their number system. But that has not always been the case. Cultures have used 5, 20, and the first cultures actually started with 60 as their base number. I am relieved that we don't use 60 as our base number anymore. But I do have a theory that our time measuring system is based on this formula, since a minute has 60 seconds and an hour has 60 minutes. And I think the first culture that came up with numbers originally used them to keep track of time. If you ever want to figure out the amount certain digits with certain base numbers make, you can follow my constructed version of the base number formula. The n's refer to the digits that you choose for your number, and the x refers to the base number. If you take the base number 5 and break down the formula, the digits now indicate how many 1s, 5s, 25s, 125s, 625s, 3,125s, 15,625s, and so on. So how do you take a random number, say 698, and arrange that amount into the 5 base number system? Start with finding the biggest number that is the base number's power that fits in your number. In this case, it is 625, which is 5 to 4. Then determine how many 625s fit in your number, which is obviously 1. Then separate that many 625s from 698, and repeat the same process with the remains, with 5 to 3, and so on. So 698 minus 625 is 73. 5 to 3 is 125, which is bigger than 73. If that is the case, then the next digit in your number will be 0. Don't be afraid of 0. Even though it is the strangest number, it is necessary for your calculations. Anyway, move your remains to 5 to 2, which is 25. 25 fits in 73 2 times. After you separate 2 times 25, that leaves 23, and move on to 5 to 1. 23 fits 4 5s, which makes 4 our next digit. Separating 4 5s from 23 leaves 3. For 5 to 0, which is of course is 1, and the remaining 3 makes 3 1s. So 698 is written as 10243 in quinary. If you don't believe me, fit the digits in the base number formula, break it down, and it makes 698. There are also other differences to consider when using other base numbers. The base number also determines how many different numerals you use. So if you use 10 as a base number, then we use 10 different numerals, 0 through 9. But if you use 5 as your base number, you only use numerals 0 through 4. This is because any other numeral is represented otherwise. If we use 5 to indicate 5 ones, it would be improper because we can represent it as 1 and a 0, which represents 1 5 and 0 ones, not 10. And instead of using 5 to represent 5 5s, you would use a 1 to represent 125. That is why only numerals 0 through 4 get used, and changing the base number changes the number of numerals. An excellent example of the number of numerals being reduced happens to be binary code, which is the code for all digital programming. It is a complicated code, but when it defines numbers, it still uses the base number system. It just uses 2 as the base number, which is why 0 and 1 are the only numerals, which indicate how many 1s, 2s, 4s, 8s, 16s, 32s, 64s, 128s, 256s, and so on. You should know that the syllable bi means 2. This is where the 2 fits in the code. Another thing to keep in mind is that the size of your base number also affects the length of your numbers. For example, if you were to write the number 1,000,000 in binary, it requires 20 digits. But when you write it in our usual base 10 number system, it only takes 7 digits. But if you were to use 60 as your base number, and supposedly had a different symbol for each numeral, it would only take 4 digits to write the number 1,000,000. So the next question I ask myself is, why did we choose 10 as our base number? Well, for starters, after you break down the exponential numbers, you are left with all numbers that start with 1 and a certain number of zeros, which is pretty simple to work with in your calculations. Also, before cultures got accustomed to writing down their calculations, they were counting off their fingers. And of course we have 10 fingers. And finally, we only have to deal with 10 numerals, which is simple to keep track of. I hope this video has been educational. Thank you.